Alright class, so unfortunately I'm away today, so I'm just going to cover the 5.3 handouts on slope via this video. Make sure you complete the handout and the textbook work associated with it. So the first part of this video shows you 4 different hills that this young lady has to traverse, and you are asked to consider which one would you rather have to walk if you had to walk home. Now, obviously, some of these hills are going to be easier to walk than others, and the thing that really distinguishes these hills is their steepness. Sorry for that messy writing. Steepness. How steep is the hill? The steeper the hill, the more difficult it's going to be to climb. So, obviously, C would be the easiest to traverse. And then B, and then A, and then D. So if we had to rank them, 1, 2, 3, and then 4, which doesn't even really look possible. But the important point for us to get here is to be considering that when we look at a line, we can talk about its steepness. Okay, so the next part of the handout shows you the graphs of presumably a business's performance, right? So in these graphs we can assume that the bottom axis is measuring time, so it's going to be like the days of the month, let's say, and the y-axis is looking at profits. Okay, so we're then asked to consider which of these 4 businesses, each graph represents a business, is performing the best. And again, we're going to be looking at and considering the steepness of the lines, but in this case we're also going to be considering their direction. I mean, are they going up or down to the right? So if we're looking at the worst, well, the worst business is the one that has the steepest line going down to the right. So that's going to be this one here. And then the next worst is going to be the one that's still going down to the right but is less steep. So that's this one here. And then the second best is going to be the one that is going up to the right but is less steep than the other. And then finally this one here would be your best, as it is the most steep. This means that the profits are going up the most quickly. And that alludes to something that's important for us to understand about steepness, and that is steepness has to do with how quickly the line is going up. Right? So if you look at, for example, this one here, this one is more steep because it is going up more quickly to the right than this one. This one goes up more slowly. Okay? So another way to think about it in terms of the graph is that the y values are increasing more quickly in this one as x continues to grow than the y values in this one as x continues to grow. So we use the word slope, you can see it here, we use the word slope to talk about steepness. Okay, when we want to talk about steepness, we use the word slope. And there is a formula for slope. The formula for slope is rise over run. Make sure you write that on your handout. Okay, so that means anytime we're trying to find, for example, if we're trying to find the slope of this line, we're trying to find how steep this line is, then we have to look at the rise here, that's how much it's going up, and its run. And we're going to divide the rise by the run. So I would answer this question here by doing 60 divided by 70. And once I divide 60 by 70, then I will find the steepness of the line. I will find the slope of the line. So I'm just doing that on my calculator here, and I get 0. Sorry about that. I get 0.8 0.571. We can stop there. Okay, so that tells me the steepness of the line, the slope of the line. The important thing for us to understand here is rise over run is how we find the slope of any line. And we always look at the change in the rise, how much the thing is going up or down, and the run, the horizontal change or length. Alright, so when working with a graph, we do rise over run, and we compare 2 points on the line. So we're comparing this point to that point here, and we compare how much did it go up from one point to the next, and how far did it go to the right or to the left. Okay, so it gives the example here in this one here. It's comparing this point to that point. The change in the run was 2, and the change in the rise was 4. So the rise is 4 over 2, which gives the slope of this line as 2. Now, a very important point to notice here, we use the letter M, and we've discussed this briefly in our class already. We use the letter M to refer to the slope of a line. I can't give you a good explanation why we use M as opposed to any other letter that would make a lot more sense. Okay, so let's practice finding the slope of the lines in these two examples. There's a couple more examples on your handouts that you should complete. So again, whenever you're finding the slope of a line, you need to find 2 points on the line that you're going to use for comparison. And you want to find points that are easy to identify. That is, the coordinates of the point are very clear. So I could use, for example, this point here, and I could use this point here. I know those points, those coordinates are very obvious to me. 0, 0, and this one is 1, 2. Okay, so if I do rise over run now, and I'll use a different color pen here. If I do the rise in this case is 2, went up 2, and it went over 1. So then rise over run, 2 over 1, gives me a slope of 2. Okay, now I'll do the same thing for this next one over here. Again, I want to choose points on the line that are easy to identify. I can choose any point on the line as long as the point is easy to identify. So I'm going to do this one here, and this time I'm going to do one a little further away, this one over here. It doesn't matter which 2 points I choose as long as they are clearly identifiable, because the slope will be the same all along a straight line. So now I can find the rise. So the rise from here, from 1 to 3, the rise is 2. And then from 0 to 4 is 4. So rise over run gives me 2 over 4. And again, the slope of my line, or not again, but this time the slope of my line is 0.5. Okay, just to a word of caution, I mentioned already you need to find points on the line that are easy to compare. And what I mean by that is I'm not going to, for example, compare this point that we started with here and this point. See, that point is not easy to identify. I can't identify the coordinates of it easy, so it does not make sense to compare those 2 points. Now, if I did know the exact coordinates of that point, I would find that the slope was 0.5 for those 2 points when I compare those 2 points as well, because the slope is the same all along the line. So a couple more examples for you here. In this case, the 2 points on each line are already identified for you. So we'll do this one here first with the A and B. And so we are then going to find the rise. So the rise here from A to B, that's going to be a rise of 3. And the run here is going to be a run of 4. So the slope of AB, do AB M, M member represents slope, is, oops, not 4 over 3, 3 over 4, which equals 0.75. That's the slope of AB. So now let's do CD, and I'm now going to find the rise. So the rise is from here to here. That's 1, 2, 3, 4, 5. A rise of 5 and a run of 4. So my slope for CD is 5 over 4, which is equal to 1.25. Okay, what about EF and HG? Let's do EF first. You might have some familiarity with EF from when we did time distance graphs. If we try to find a rise, we find that there is no rise. If we look at the run is 3. So if I do the slope of EF slope equals 0 over 3, that gives me a slope of 0. Okay, so horizontal line has a slope of 0. Now let's try HG. And if I look, the rise of HG is 1, 2, 3, 4, 5, 6, 7, 8. It's a rise of 8. Oops. It's a rise of 8. And the run is 0, right? It's not going anywhere to the left or right. 8 over 0. 8 divided by 0. I can't divide anything by 0, so this slope is called undefined. Alright, so hopefully you've gotten this idea already, but if we are drawing out our slopes, a positive slope, it's always going to be going up to the right. Up to the right. Negative slope is going to be going down to the right. A zero slope is a horizontal line, and an undefined slope is a vertical line. Alright, so example 3. Use the slope to find a point on a graph. A line segment has one endpoint, 4, 3, and slope -5 over 3. Find the coordinates of another possible endpoint B. So let's first find the point 4, 3 on our graph. So our point 4, 3 is right here. And it says it has a slope of -5 over 3. Now remember what slope is. Slope is rise over run. So 5 over 3 means that 5 is the rise and 3 is the run. And if it's negative, that means the line's going to be going down to the right. So if the rise is 5, then I can count 5 down from 3. That's going to take me to -2. So down 5 from 3 takes me to -2. And then over 3 to the right for the run from 4 is going to take me to 7. So this point here is 7, -2. And that is another point on this line, 7, -2. So that line, so I'll label A, so this was A, and I found B because the line that I've just created, now I'm going to try and connect them, it's not going to be pretty. Not too bad. Connect them, that line has a slope that is -5 over 3. Now I could go the other way as well, because I could find 3 over from 4 going this way. It's going to take me to 1, and then up 5 from 3 is going to take me to 8. So then that point is 1, 8, and I can identify that on my graph as 1, 8, and then I could connect that line. Okay, that's another possible B. Okay, so that's how we do that. And what about if it was a line, question B here, a line segment has one endpoint, S, -1, 2, and slope 3. So let's find s first. Negative 1, 2 is going to give us this point here, negative 1, 2. And it says it has a slope of 3. So let me see if it'll let me erase what I have here so I can, yeah, well, I guess I can write that. So if it says slope that is 3, now remember slope is rise over run again, so that would mean the rise is 3 and the run is 1. Okay, because rise over run. And if I want a slope of 3, it means 3 divided by 1. So that means I can, and remember it's a positive 3, it's not negative 3, so that means the line's going to be going up to the right. So that means I should, from the starting point that I have, which is negative 1, 2, I should go up 3, 1, 2, 3, that takes me to 1, and over 1, that takes me to the point 0, 1. And I can identify that point on the graph. And then I'm going to draw a line to connect. I know it's not pretty. And that is a possible point T. And there are, of course, other possible points of T. I would encourage you to find as many as you can in order to complete the handout. Alright, so a quick review. Slope is a measure of the steepness of a line. It's the most important idea for you to get from this video and from this handout. The formula for slope is rise over run. A line with a positive slope goes up to the right. A line with a negative slope goes down to the right. Horizontal lines have a slope of 0, and vertical lines have an undefined slope. Those are the central ideas you should get from this section 5.3. I think one thing I would add that I don't have there is that we use m to denote slope when we are doing linear relations. Alright, good luck on the handout and with your textbook homework.